Hello. Also, in this video, we are going to discuss about the basics of Xilinx ISC Design Suite 13.2. So, it is used for VHDL programming and also other hardware description languages like Verilog and many other languages you can do. You can do programming in using this software. So, this is how the page looks when it opens. After you install the software, when you open the software, you can see a page like this. So here we are going to do the VHDL coding. You can also do Verilog coding, as I said. So we will be seeing a simple AND gate design, how to do the behavioral coding of simple AND gate. The first thing you have to do is click on new, create new project. Okay, so then it opens a window like this. You have to give various fields here. The first is name. You can give a name of your project. You're going to create a new project. You can just click on that the box and you can just give sample one. I have given sample one as a name. You can see the location in which it is getting stored and the directory. You can change these things according to your wish. Wherever you want to store it in your computer, you can give according to the details, whatever you are willing to. Okay, description is optional. If you want to give some details about what project it is and those things, you can give the description, but it is completely optional. The next part you can see is a drop down where you can see the type or the source type. It is, there are various options available. HDL is hardware description language. That is electronic circuit design based on hardware you are designing. So it is hardware description language. Next option you can see is the schematic. Okay, so schematic diagrams you can design. Second option is schematic. Third one is EDIF, that is electronic design interchange format, is EDIF. Last one is NGC/NGO. It is like for importing a design file. So these are the options available. We are going to use like HDL because VHDL is a hardware description language. So we are going to select the option which is called HDL. So if you are doing some other things, you can go for those options, whichever option you are going. So I am going to select HDL here. So I have selected that and then click on next icon. You can see it on the screen. So just select HDL and then click on next icon. Then you can see again a box which has a lot of specification. So most of the time we are writing the VHDL code for burning to a board, right? So it has say a certain specification. So it has to match with these to make the burning of the code to the software, that is to the board, easy. Okay, so what are the various fields? Let's have a look. Most of the things we are using as default, whatever it is there, we will be using that. First one is evaluation board. You are not going to do anything on that field because we are just writing the code. Then product category, we are selecting as all itself. Family is FPGA family. Different types of FPGAs is there. You can select from the options whatever type of FPGA you want to use. If you are using a board, if you are going to connect a board to it, and if it is of specific FPGA family, you have to select that family itself. Now what I'm going to do here is I'm going to select Spartan 3. That is the FPGA family which I'm going to select here because it doesn't really makes any difference because I'm not going to burn it to a board. So just select Spartan 3. Then most of the other things are whatever is there by default, we'll be using that. Device, whatever it is showing, just use it. Then package, also same. So most of the things, as I said, it is the same thing which we are going to use. Then make sure that the preferred language is VHDL. So if you see these things like synthesis tool, everything is the same. Whatever it is showing, just go as per the same thing. VHDL should be the preferred language. You can also see VHDL and Verilog. Mostly this is used for coding in VHDL and Verilog. So I'm going to select VHDL because I'm going to code in VHDL language. Okay. All the other things you just keep it as default. Whatever is there, just keep it as default. And one more thing you can see, you have to give simulator as ICM simulator. It is an inbuilt simulator for Xilinx. When you are seeing the simulations, you can see it is having a ISIM simulator window will be opening. So that is the default simulator. Click on finish. So your project is now created. Next, we have to create a source file. So in that source file, we will be adding the VHDL code. So next, you have to click on the icon, and then you have to click on new source. You have to select from the options VHDL module. After selecting that, you have to give a file name. You can just give any name to the file. So in that file only you will be writing the code. So I have given sample 123. Then click on next. Then you can see you can define your ports and the directions. So this is the input and output ports we are going to define here, and you can also select options like in out or in out. So this is a basic AND gate. You just need that is a 2 input AND gate. So I am going to give like 2 inputs and 1 output. So port names you have to give. You can give like A, B, C, A and B input ports and C as output port. So here first you are going to give the name of input port. I'm going to give A, select it as input. B also input. C will be output port, so select the option out. Then next thing is click on next after giving these details. So in the basic videos of VHDL, we have discussed about ports, the type of ports, input, output, what is input, what is output, what is in, out, what is buffer, those things we have discussed in detail. So next, click on next and then finish. Okay. Now your sample file is created. You can see many of the things are being written for you. So you just have to write the logic. All the template for your code or for your source file is already been created. You just have to add the logic. That is how this module is going to work. You just have to add the logic. You can see the library files on the top, library IEEE, use IEEE.std underscore logic underscore all. Then entity is also declared based on the port details we have given A, B and C. And they have given the name as sample 123 because we have given the name as sample 123 for this file. And then architecture behavioral of sample 123 is begin. After the begin, we have to write our logic. Okay. Here, if you see, A is in std logic and B is in std underscore logic. C is out std underscore logic. So these std underscore logic these are data types which can take 1 and 0 values. Those data types are already present in library IEEE file. Okay, so this library file will be having all the built-in data types and those details. So you just have to import these two library files to make sure your program is working good. Okay, so after the begin, we are going to write the logic for a simple AND gate. So after we write the logic, then we can see there is n behavioral also. So the template of your program is already been created. Just put the logic for the AND gate. Okay. So after this begin, I'm going to write the logic. So you will be simply using AND operator. So also the Boolean AND operator, OR operator, NAND, NOT, all these operators are again defined in the library files. So since we have already imported the library files, we don't have to again go for any other things. You can simply start to using the Boolean operators here because those things are already been defined in your library files. So after the begin, I have written the logic for a 2 input AND gate. You can see C equal to, that is assigned a value A and B. On this side, you can see there is options for running. You can also separately run various things, and you can see the results. So I'm trying to run my code after saving it. So you can see a triangle icon for running. So just click on that icon and you can run your code. Various things is there, various steps is there for running. Synthesize is there, implement design, generate programming file. So those are the various steps, and you have to go for implementation first. Select from the option, select implementation, then you can go for simulation. Okay, so first you have to run your code by clicking on that triangle icon. Then you have to generate your programming file. After the programming file is generated, then go for the simulation option. Then you have to select that module, and then you can see that iSim simulator is being shown, and then click on that simulator or simulate behavioral model. Then click on, you can right click and you can run. Now it is running. Now we can see that simulator window will be opening. So it is opening the simulator window. Now we can see the simulation results. So this is a simple way of seeing the simulation results using iSim simulator. You can see the input ports A, B and C. The values are undefined because we have not really defined any values. We can force the values to A, B and C here. So if it is not defined, it will be just showing as undefined. But you can give values. Right click on the option and you can see you can force clock or force constant. Click on force constant if you directly want to give as values. If you want to give us a clock, click on force clock. So I'm going to select force constant. You can select the values as 1 or 0, whatever value you want to give. Just click OK. For B also do the same thing. Give the value and then click OK. Apply and OK. First apply, then OK. Then you can run and see the simulation results. You can see there is a run option here which will show you the results. Just click on somewhere on this graph or that green part. You can see the values also showing there. Okay. Just give one more time 1, apply, OK. If you want to give 1 again and run it again, you can see the results coming. Okay, so just like this you can give different values. As I said, if you want to give a clock, you can directly give a clock, or if you want to give a directly a value, you can give. See, if you press on this magnifying glass, you can adjust the simulation window and you can see all the results that have come. Okay, so this is how you just give a force constant. Now let us try and see how to give a force clock. That is, we are going to give clock signals for A and B input, and then we'll see what is the results coming. Okay, so in order to do that, you have to again right click on the values. Select the option force clock. Leading edge value, trailing edge value, you have to give 1 or 0. Just select that is give all other options as default. Period, you have to give 1 microsecond. Click on apply, OK. Next, for B also do the same thing. Change the values according to your interest, 0 or 1 for leading and trailing edge. Again, period is 1 microsecond. Apply, OK. Now you have to run. You can see the results are coming. If you want to give continuous result, run continuously. You can see the run continuously. That is, it is running continuously, and you can see the results changing. Just adjust the magnifying glass, and then you can see the results in a better way. Yeah, see the results are changing because clock is continuously getting generated, and based on the clock, the results are also varying. Yeah, this is how you can see the results in the iSIM simulator simulation window. So that was a basic introduction for Xilinx design suite. We have also seen the simulation window, how it works and all those things. So if the video was useful, please continue watching this series.